Okay,
I think we are recording. So yeah, welcome to our first meetup of this year. And another time, happy to welcome Kris in our group. And with that, I hand over to you.
okay, great. Thank you very much. Yeah, appreciate everyone coming tonight, and welcome back to those of you who joined me towards the end of the year last year, where I was talking more on the topic of data warehousing and looking at the modern data platform and how you can utilize that for large amounts of data processing prior to the consumption in Power BI. Today, we're going to take a look at actually how you can work with larger amounts of data effectively in Power BI. And the reason this is something that actually is very close to my heart, because there is one thing that annoys me more than anything else in the world, and it's when I'm sat down in front of a Power BI report and I've got this little blue donut of doom circling around. You know the one I'm talking about. I hope you do, because everyone's experienced it. Yeah. And I'm just looking at it, waiting. I'm scared to click. I'm scared to press a button. I'm scared to do anything because I know that Power BI is just going to pile in and just die. Yeah. And then I got to restart. And maybe add some transformations that I had to before. I mean, this really does annoy me. Not only that, but I also notice the people that I work with, in the room who are also working with Power BI, sat like this with their hands over their chest, and they're a bit annoyed and a bit frustrated, but they're waiting, and then they go grab a coffee, and then they come back, and they're still waiting. They're waiting on Power BI to do something, to carry out that next transformation. So actually, effectively, from 1 hour of production time, so I'm talking about 1 hour of development time in a Power BI report, they actually get about 15 minutes of actual productive work, and the other 45 minutes is generally spent waiting on Power BI to do something. So I hate it, so I like to iron that out pretty early and not wait on Power BI. So I'm just going to give you some tips. They're not going to necessarily say that this is something that you haven't seen before. You guys are all busy in the community. You've seen posts from other people like Nikolai zum Beispiel, So who is, he's a bit of a guru as far as Power BI query performance is concerned, and he has covered the lot extensively. I'm going to go into detail, so some details, and if you want to see more, then we'll open up with the opportunity for questions. I've got lots of demos, and that's important. For those of you who don't know me, my name's Kris. I'm living in Germany, working in Germany, originally come from Scotland. I'm the head of analytics here at LMIT Services. I'm still a huge fan of the technology, can't really get myself away from it. So I'm always playing around with Power BI and the modern data warehouse stack. If you've got any questions ever, feel free to reach out to me because I like to chat about it. It's just finding the time is generally the problem. I also like to chat about Formula One. So any Formula One fans, I mentioned this before. They're few and far between, but I do like it. And there were a couple the last time. It's gone crazy. New rules, 2022, lots of new cars, exciting stuff. Looking forward to it. And I'm looking forward to just meeting new people. That's why I'm here tonight, sharing my knowledge. I'm happy to have a knowledge transfer. So please add me on LinkedIn, connect with me, reach out to me for a chat or a coffee. Even a virtual one, I'm happy to do anything. So the last time I was here, I'd spent a long time presenting. It was almost 2 hours. I'm going to cut it down a little bit today and not overdo it. Don't want to exhaust you guys with the first one of the year or set the expectations too high. So I'll try to keep it around about an hour and then save some time for questions. But this is what we're going to cover today. So we're going to look at query performance, and then we're going to look at some of the methods that we can use to reduce the amount of data that we've got, because that's generally where the problems arise that we have as far as query performance is concerned. So we want to get rid of what we don't actually need. Then we will look at the performance optimization techniques. So what sort of things you can do to better optimize your performance. I'm focusing more on large amounts of data here. So I'm not talking about how you can optimize the performance of that 20 megabyte Excel document that you're trying to look at. I'm talking about several gigabytes of data from a database that you can import into Power BI and optimize how you work with that. That's why we've got that topic, query folding techniques, because we're looking at how we can utilize query folding, what benefits it actually gives us, and I want you to see it in action as well, so that you can understand, okay, I can see the difference between something that is not query folding and something that is query folding, and then you will really be able to see for yourself what kind of benefits you're getting from it, and also maybe just try it out. And that's when we come to the query diagnostics. For those of you who haven't worked with query diagnostics and Power Query before, I want to show you how you can use the query diagnostics to understand what is going on in your transformation steps, what is taking so long, and what you can also do to reduce that time. Yeah, so where we say, do you really need that transformation there, or can you move it somewhere else and do it somewhere else? And this is just what we're going to look at. So it's a lot about optimizing how you work with Power BI as well. So lots of demos and not so much PowerPoint. There is some PowerPoint. It's a little bit bland. I do apologize in advance. Not had a great amount of time to really spend focusing on the PowerPoint, but I know that Arthur will draw a great sketch at the end, and we'll all be happy with that. So, so what do I mean when I'm talking about query performance? I've already covered it relatively briefly. I'm talking about Power Query, because Power Query is the part of Power BI that I'm using to get data from, and that is where my queries are being run against the sources that I have in the background, and also that is where I'm going to hit my first sort of walls when it comes to performance. And I want to identify what it could be that is slowing me down and what's going on in the background so that I can actually optimize it. And it's all fine and well just sitting there watching that little blue donut of doom circling around and waiting for it to go away, but it'll just come back the next time. Yeah, so I don't want it to come back. I want to get rid of it for good. Yeah, and that's why I want to understand what's going on in the background, what's going on underneath the hood. Yeah, so that I can get rid of that. So in order to do that, and in order for Power BI to perform effectively, we really need to be using the import mode. Yeah, so you've also heard Power BI, we do have the import mode, we have the live query, the direct query, then we've got the composite model, which is a combination of the direct query and the import mode. Yeah. We want to focus here in this session on using the import mode, because import means that we can load the data, all of it or as much of it as possible, into the Vertipack engine that we've got in Power BI. That is where we're storing the data. That's where we can really utilize the performance. It's an in-memory column-based storage engine that we can utilize, and we can really, we can really gain a huge benefit using that against going direct query against the data sources themselves. Don't get me wrong, direct query is I'm not writing it off. It's good to use for large amounts of data that we can't fit into this capacity that you can see here of 1 gigabyte limit that we have for our data sets within our Power BI desktop files. Yeah, so that's the maximum that I'm going to be able to use or upload to the Power BI service. But when you start moving into other realms like premium capacity, we've got a 13 gigabyte limit. I'm still limited in the amount of data that I can save in my model in Power BI desktop to 1 gigabyte. But how do I then get up to 13 gigabytes in the premium capacity? I'm going to show you that later on as well. I'm not going to upload 13 gigabytes of data because then we'll never be finished, because we will just be waiting on that blue donut of doom to finish. I'm sorry if I've raised the bar too high right at the start, but I will show you what sort of things that you can do. And also when you're working even with several hundreds of megabytes of data or a gigabyte of data, for example, what you can do to really increase your offering. So it's about you being able to develop your Power BI report effectively and efficiently, and then upload it to the service and let the service do the heavy lifting for you. Let it take care of the rest of the data. Yeah? So we've got several techniques. One of those is data reduction techniques. Yeah, you've heard it all before. I'm not talking about anything new. Yeah, people always say it, get rid of any unnecessary columns that you don't need. Here we are looking to get rid of columns that have a high cardinality. Yeah, we don't want those taking up lots and lots of space. We have a column-based compression system in the Vertipack engine. So it is basically just saving each value that we have once, and then generating an index to reference this one single value every time it appears in a new row. So therefore, it's pretty efficient because we're not saving that same value a million times or 10 million times, for example. So that's where we've got a huge amount of compression going on. But in order to understand what you need to actually, or what you can actually get rid of in the first place, I like to, right from the start, sketch my data model. Yeah, it sounds very simple, yeah, as a data reduction technique, but all too often it happens that people turn around and say, hey, I want to get my data out of SAP. And then they go to SAP and they say, okay, I need that table, I need that table, I need that table, I need that table. And then they just pull all of those tables and all of the columns within it into Power BI and then wonder why they're actually sat there waiting. Why do we not do it the other way around and say, what I want to find out is this? And in order to do that, I require this column from this table and this column from this table. And I actually build my data model first. So I've got my data model, and then I can just go back to the source. Got a nice star schema because I know that that's what I need to ensure good performance. Not covering modeling today. I'm covering query performance. Modeling can come at a later date. But this is something that's important, or is one of the early steps. Another data reduction technique that we have is to get rid of unnecessary rows. Yeah, so we've got rid of the columns because those are the ones that are taking up the most space, actually. Yeah, because we're talking about those with a high cardinality. And I'll show you an example of one of those taking up a lot of space. But the rows are also taking up a lot of space. Don't forget it. Yeah, we have. In the examples that I'm going to be using today, I am working with around 20 million rows of data. Now, that's generally quite a lot for Power BI desktop. I know that several people would maybe here might have worked with more, of course, yeah, in the import mode, but it's still a large amount. And it was a balance between being able to show you stuff and so that you can actually see it for real and not have to wait too long, because Power BI is good, yeah, but it's not magic, yeah. It's not like a little black box of magic that's just going to perform when I want it to. So therefore, but I'm still working with a large amount of data, and I'm going to show you different ways that we can remove the unnecessary rows. And one of my favorite ways to remove the unnecessary rows is the use of parameters. And that's actually the way that I would recommend, because you will benefit from it in the Power BI service as well. But I'll show you that in the demo. It take too long talking about it. Now, this is a method that is suggested by a lot. Group by and summarize the records. Yeah, okay, that's all fine and well, but grouping by means that I'm going to lose a level of granularity. I always have to be aware. So what data am I working with? In the demos, I am looking at streaming data from Spotify. So looking at the Spotify charts over the last 10 years. And if I wanted to, look at the charts at a daily level, then I need all the data that I've got there, because I'm getting daily information delivered in my report. Now, if I want to group by, I don't really have too much to group by. I would have to lose granularity on my time dimension, on my date dimension. So I would need to go back to a week or a month and then aggregate the data there, but I lose that level of granularity, and that's maybe not what I want. So it's not necessarily my preferred method, but it's the method that you would most likely have to use if you're hitting that 1 gigabyte threshold where you've done everything else, but you've still got too much data. Yeah? And that's generally if you're streaming data from IoT sensors and you're saving that somewhere, you've got seconds data that is delivered by the second. Do you really need by the second granularity, or could you aggregate up to the level of 1 minute? Something to consider. But this itself in Power Query it's an expensive operation, because it needs to go through all the data. So that's what we would look at and say, those are expensive operations in Power Query, those operations that need to look at every row of data, because it needs to pull it and then it needs to aggregate it. Yeah, so those in Power Query are generally quite expensive. So therefore, I tend to avoid it unless I really have to use it. Others will see that differently. I look forward to maybe a discussion later on. Other data reduction techniques that we've got are the optimization of the data types. Not to be underestimated, we have spoke about the indexing system for the column-based values. We refer to that as hash encoding. So it takes that value, Yeah, and then gives it a hash value. It's an index value, and then it utilizes that to reference it in every other row. We also have value encoding, which is it's a different technique which is utilized for the encoding of integer values, so numeric values, where it doesn't have to save every numeric value, but it saves one of the numeric values and that maybe comes across most often, and then it uses the others to add and subtract in order to reach those specific values. So therefore, it's reducing the amount of data that I have. Only works against integers, whereas hash encoding is for text values. And also consider cardinality here. Take a look at your columns. I've said it before. I will keep on stressing it throughout the whole lot. Do you really need that column, that ID column, or is it just a database ID and not necessarily a business key? So something to just be aware of. Then we have custom columns. I would also disagree with my first statement, which says define in Power Query with M as opposed to DAX calculated columns. That's more a modeling topic and for another day. But even then, I would still avoid creating custom columns if I can in Power Query, and always look to create them at the source first. So that means if I have the opportunity to go back to the database and I can create a view where I can then create a column, so a calculated column based upon two other columns, then I will try to do it at the source by creating a view first. If I can't, then I will do it in Power Query with M as opposed to doing it in DAX with calculated columns, especially when I'm working with string values, because that's not really where DAX performs at its best. So I want to come back and look at trying to do this as far back in the chain as possible. In housekeeping, housekeeping is generally important. So maybe looking at sort of the options that we've got where I can disable the Power Query background loading that's going on because maybe I don't need it. Maybe I can just work with what I've got, or disabling things like auto date time. Now, this is something that you probably heard before, that for every date time column that appears in the reports that you, in the data sources that you are pulling from, there is an auto date time generated in the model for this so that it can take care of the hierarchy for later on. And this takes up valuable space in your model. So it's just something to be aware of. We're not really going to see that today as far as the housekeeping is concerned. It's just please take this tip with you into the future. I'm going to be looking more at the raw data issues and not necessarily the housekeeping stuff that we've got. But it's there just to be aware of. Only a few more slides before we get to the demos, so hold on tight. Yeah. Then we've got performance optimization techniques. So always, where possible, work against a temporary subset of your data. Yeah. So take a subset, a small amount of your data that has been validated and tested, and use that. But ensure that you've also got enough data where you can create your measures and your KPIs then later on. Because if you're working with that, it's going to enhance the time that it takes for the authoring process. As far as creating the full report with all the data is concerned at a later stage, that's not an issue by any way, shape, or means, because you guys have the opportunity to fix that in the Power BI service and let the Power BI service do the heavy lifting. We're going to look at the options. Profile your data. Now, this was something that came up in a post from Catherine Burchard. I think that's how you pronounce her second name. She showed today, actually, in a post on LinkedIn, that you can, or was asking the opinion, do you guys profile your data and in Power BI? So profiling is the ability to look and check the quality of your data within Power Query itself. Maybe you've seen it. I will go through the options and show you. This is something that I generally don't do in Power BI if I don't have to, because it uses some performance in the background. But if I have to, so I'm working with a data set that I maybe can't check the quality of in a different way. So, for example, an Excel file that's pretty long, then I would profile once. So I turn on the profiler, look at all the available rows, profile the data once, make sure I've got everything that I need, that it's in good order, and then I turn that off again as not to use too much background performance. Modular approach. A hugely underestimated approach is how you actually create your transformations in Power Query. I'm going to show you what I call the good, the bad, and the ugly. Yeah, this is how you approach, or how you might approach your Power BI development work, and where you can see that if we adapt a modular approach to that, how much time we can save and how much that really does affect performance. I've done it on a small scale in this example that you will see today, and the results are actually pretty impressive. So you'll see for yourself. Any expensive operations that we do have to conduct, for example, a join or a sort or something like that. I don't know why you would have to conduct a sort, but for whatever reason, if you do have to order data in a specific order in Power Query, then push it to the end of your transformation steps. The reason why is these expensive operations could have an effect. Well, could have an effect on query folding, especially something like sorting data. It's not necessarily going to interrupt that. But we want to move the expensive operations to the end so that we can then flick through the other stages if we do happen to have an error and not necessarily have to wait on that thing that is going on in the background at the end. That would be an instance where I maybe do want to leave Power BI actually operating in the background. And then I've got housekeeping as well for performance optimization techniques, where I would say use groups to group your queries and document your work. That seems pretty self-explanatory, but I'll just show you a quick way to do it in Power Query. You might have that aha effect. You might already be doing it. It doesn't necessarily optimize your performance, but it optimizes the performance of offering a report that you've just picked up from somebody else. I'm head of analytics here, so that means I'm working with reports that other people have built. So when I go in, sometimes I'm trying to figure out what is head and tail of this report. I don't understand what transformations have been done and why, and I also don't understand the queries and how they're set up. If you just implement some simple housekeeping rules, like the use of groups and documentation of your work, then it means that it makes life easier for anyone else who comes in and wants to pick up your report in order to make changes, or it makes it easier if you're picking up a report from a colleague. We will look at query folding techniques. You have probably heard of query folding. You probably know what query folding is. You've probably seen it in action yourself. It's pretty simple, yeah, in the theory, but it seems to be the sort of big buzzword that's going around all over the place. But it is where we use, as it states here, a single query statement to retrieve and transform your data from the source. So that is where we can just, within the steps, actually, a SQL query is built and it is sent natively back to the source, where we then where it is run and a result set is given back. Yeah. Now this, as you can imagine, is quicker because we don't have to go through some sort of transformation of languages from the M query to then create an SQL script out of it in order to go back and ask the service, and then it dramatically increases the performance that you've got in your report development. It only works for relational databases and OData feeds. It won't work against your lake databases necessarily. Yeah. It won't work against your data lakes, but it will work against your lake databases. And that's something that I showed in one of my other videos that you can see on the YouTube channel. If you haven't checked it out, then go there and do that. There's a bit of a cheat sheet here, just to keep it simple. What can be folded, what can't be folded, and some best practices. The general rule of thumb is to say, I can fold anything that I would normally, that would natively be able to be done on the SQL Server itself. So if I'm looking at my SQL Server as a source, and I can conduct some joins, I can do a conversion of a data type, I can use a where clause, I can apply a filter, on the where clause, or I can provide an order by, for example. Then if I can do that on the data source, then I can generally except that I'm going to get query folding, which means it's always going to be pushing these queries back to the data source to increase performance. So we will look also at query diagnostics. This is my favorite part, actually, and this is the first report that you will build in Power BI in the future. Yeah. So once you've done all your transformations in Power Query, before you get started with your model, you will just go straight into Power BI and build a query diagnostics report so that you can get a feel for the transformation steps that you have taken. Are they going to work? Not only are they going to work, but are they going to scale up when you're using much larger amounts of data? Yeah, so that's something that we want to look at. So here's the demos. We will do some demos on data reduction techniques, talking about getting rid of it. Yeah, we will do a demo on the modular approach. I also mentioned the good, the bad, and the ugly. We will look at query folding in action and also query diagnostics. So where we can get, as I mentioned, the first report you will ever build. This is actually really nice because I go to a customer and the customer says, my Power BI report isn't performing. I look at it, I don't understand it, but I can just throw a quick query diagnostics on, build a report, and then I know exactly the problem areas that I need to look at. Yeah, which is generally quite nice. So I will get on with the demos. So that you can better understand the demos, here's the scenario. It's not a business scenario. I do apologize, yeah, but I wanted to keep it away from daily business life and just have a bit of social life, yeah, even though I'm talking about Power BI in the evening. But I started off with a CSV file. The CSV file contains information about Spotify charts worldwide for the last 10 years. So I downloaded 3.3 gigabytes of CSV data, and from that 3.3 gigabytes, I loaded 20 million records, maybe just a little bit more, into an Azure SQL database. So not a data warehouse, just a standard Azure SQL database. For those of you who are interested in how it's scaled, I'm using the DTU 100. Yeah, if you want to know more, then speak to me after the meetup tonight. It's a single flat Excel file that I downloaded. And then what I'd done is I just put the single flat Excel file directly into the SQL database, because I would not be able to work with Power BI and a single flat Excel file of 3.3 gigabytes in size that is a CSV. It will just not work. We're not compatible. Yep. So that's why I just threw this data at a SQL database and said, okay, I'm going to work from it from there. And I filled a table, as I said, with 20 million rows, which gave me just over 3 gigabytes of SQL Server data. So I have a single table in SQL Server, 3 gigabytes in size. So scenario one, and I will open up my first Power BI report. This is scenario one. So just to give you a feeling for what's actually going on, I have the source. It's sat in my worldwide importers data warehouse database that I have, but it's just added as an additional table. And here I have selected that single table. It's not necessarily clean. Please don't worry too much about that. Yeah, but I have here 9 columns of data and over 999 rows of data. I have 20 million rows of data. Now, we spoke about the size of the data in SQL Server, and we spoke about how Power BI automatically will compress this data to put it into the model using the Vertipack engine. And I can gain an insight into that just by looking at the size of the file itself. So if I just take a look at the size of the file from this scenario, which I will show you in a minute, it is 172 megabytes in size. So I'm not loaded 3 gigabytes of data, but I've got 172 megabytes of data in my Power BI report, just to give you a feel about how it is on a one-to-one comparison. That took me 30 minutes to load this 20 million rows into Power BI. So that means when I clicked on close and apply, yeah, and wanted to load my data into Power BI right here, then that took me 30 minutes to get to this stage. I still have a flat table. It's not exciting. All my columns are text values because as I imported it, I just went from here to there, CSV. I don't care. I don't want any errors. I don't want any problems. Just import my data, please, exactly as it is. And I got everything that I wanted. So now if I want to work with this 20 million rows of data, it's generally going to be slow. So the first steps that I should do is I want to look at data reduction techniques. So one of the data reduction techniques that I could use would be to get rid of any columns that I don't need or get rid of any rows that I don't need. Now, if I want to get rid of rows, I've got several options, as I'd mentioned before. I can go here and say, hey, keep rows. So give me a top amount of rows, yeah, and I can say keep the top. I'm just going to be a little bit crazy here and go for 1 million. So want to keep 1 million rows of data, yeah, to give me a good feel of what I'm working with. But that was okay in general. It worked pretty quickly, yeah. So I've got 1 million rows of data that I'm now working with, and it didn't take too long to complete this step. I don't have a blue donut of doom, so I'm still feeling pretty good about this scenario. The only problem I do have is this 1 million rows of data that I have has not been determined by me. I've let that be determined by Power BI, which is also in the background being determined by my database. Yeah, so the SQL Server engine is the engine that is non-deterministic, so it will decide how it provides those 1 million rows of data for me. Now, I'm only seeing 999 rows plus. Yeah, so the problems start to occur when I scroll down. Yeah, a little bit further. Yeah, and try to get past that 1,000 mark. Yeah, that's when these little dots start appearing across the screen, and it's trying to go and get me the next 1,000 rows of data for my 1 million rows of data. It has a problem. Yeah, it has a problem, but I can see what's going on. If I click here on the right-hand side to this first row step, I've got this nice view native query step, which means I'm getting query folding. So in order for it to go back and get me this, then it's going to go back and get me the top 1 million rows. Yeah, non-deterministic. Now, I don't like it because I'm still going to have to wait a long time. If I was to profile my data, and that would be to look at things like the column distribution, the column profile, and the column quality, it's all fine and well for looking at the first 1,000 rows. That's going to happen generally pretty quickly. But if I want to profile more data, I need to be looking around here, somewhere near the bottom, to say column profile is based upon the top 1,000 rows only. I'm going to put it over the entire data set, yeah. And I don't have this blue donut of doom that I was talking about, but I've got lots of other donuts of doom doing lots of things in the background that I'm going to be waiting a long time for. Yeah. So in order for me to proceed, yeah, I need to wait a while. This is one of the reasons why I said I don't generally do the profiling at all here. I will try to do it in the SQL Server itself, but if I don't have a choice, like I'm using an Excel file, then it's probably going to be smaller than the several millions of rows of data that I've got anyway, and it's the impact is not going to be too bad. But here I'm going to, as you can see, spend a lot of time waiting. Just going to turn these off. Yep. And I'm going to kill this first rows that is going on in the background at the minute. So there we go. I'm happy. I've got Power BI back to a state that I want it in. Now, another option would be that I actually provide a query. So if I just, look here, I do have a native query. So if I'm unsure, I can see what query is being conducted against my database in the background. And I can take this query and add it as a native query, as a new query, for example, and then run the query against the database where I say select top 1 million. Can't type in here, sorry, I will just copy this out. Yeah, just for the purposes. Run a new query against SQL Server, yeah. So I do have the option to put a query statement in here where I could say select my top 1 million, for example, yeah, and that would then run against. Obviously, I need the server information. I haven't included it in here. I've got it in another demo, but I just want you to understand the purpose. Yeah, so I could do this, but the effect is still the same if I'm selecting these keep rows, because as I said, keep these top rows, yeah, and then put in 1 million here. I can then look at my native query to understand what's actually been sent back at this point to the SQL Server. And I can see that I've got my top 1 million. I'm not sorting. I don't have a predicate that's deciding where I'm going to filter. So therefore, it's going to be this non-deterministic value. And when I speak about non-deterministic, the SQL Server engine is going to decide for itself. It will decide for itself based upon a couple of factors. And those factors are, is there a clustered index on my table, or is there a non-clustered index on my table that I can use to deliver the information more efficiently and more effectively? If there isn't, then it will just create a heap and then try and provide the top million. If there is an index, it'll use it and just get the top million relatively quickly. So indexing is something that is important, but that's something that I have to do back on the source system. The ideal way that I want to be able to filter data is I want to be able to say what data I want to filter. And generally that's going to be done upon a date column. Yeah. So when I go here and I want to filter this, yeah, for example, use the right options. So I want to filter this, yeah, but I've only got a text filter. I don't have the ability to filter by a specific date. That's because I'm not using the right data type. Simple. So I'm going to change the data type here, and I'm going to throw that to a date, for example. That's all fine. That's worked. I've got the ability to then filter here per date, and then I can close in a period. But I have a problem. I've lost the ability now to be able to query fold. And that means for this query, I've lost the ability to be able to query fold after this step as well. Now, that's not generally normal behavior for when I want to change a date type, when I want to change a data type. Yeah, but in this case, it is. It can't natively figure it out, so therefore I've lost the ability to query fold. So this is something that you just should be aware of when you're adding a transformation step. Do I lose that ability? So I've lost that ability, and I don't want to lose that ability. So therefore, I'm going to cheat a little bit. Yeah, I'm going to get rid of this Power BI demo, and I'm going to go, here's one I made earlier. Yeah, here's one I made earlier. This is just opening up. So give me a second. Shouldn't take too long. Only got to do this a few times. Yeah. So here's one I made earlier. What I've done here is I've defined the data types at the source. So I have said that I want to create a view. So all I've done is just created a view in SQL Server, fairly simple. And I've just defined the data types in this view so that I'm using the right data types where I should be. So for the rank, I'm using an integer value now, and for the date, I have a date. And actually, this has saved me some space. 2 megabytes. So I had 172 megabytes at first. I now have 170 megabytes. It's not groundbreaking space saving. Yeah. But what it does allow me to do is it then allows me to filter my date over a specific period. So I will just add a custom filter, keep it relatively quickly, and say is before or equal to sure what date I've got in here, but just go there, and after or equal to the 16, for example. Yeah. So I'm then able to apply a filter. Now it looks here like I've also lost the ability to query fold moving forward. I have filtered the data. It didn't actually take too long for 20 million rows of data. Why did it not take so long? That's because I applied a non-clustered index to the table in the background. So those 20 million rows has a non-clustered index on the predicate that I'm filtering, so the date, and therefore that allows this to perform relatively quickly. As you can see, it's finished doing its work, yep, and I can check the step, and I do have a query fold going on here. So it is taking this query exactly as it is now and going back to the source system and running that against the source system. It's still, don't be, oops, did I press something? Press the wrong one, sorry. It is still, if we look one step before, running this query too, yeah? It's running this query, and it is also running this query. It's running two queries now against the source system. So just be aware, just because I've got query folding going in the background, it doesn't mean to say that I'm not actually running those queries. It's running all the queries for all the steps every time. It's just doing it a little bit more effectively than if I was creating these steps myself, because then I'm moving as much of it into the system, which is my laptop, where I am developing the report, and then I'm putting the pressure on my laptop. Now I'm putting the pressure on the source system and letting the source system still take care of all the heavy lifting. Hence the reason it was so quick, because I created an index at the source system, and I'm not moving all the data into my laptop, into my memory here, to then try and filter it. So therefore, I got this added benefit. So that's all well and good. I'm able to filter by a specific date. But that doesn't really help me when I want to deploy this report to the Power BI service, because at some point I would have to take this filter away and then deploy it to the service. It does help me acutely to be able to develop effectively. I'm working with 1 day of data now, so I can pretty much do anything here, and it's going to happen fast. Yeah, it's not going to be slow. It's going to happen fast. Okay, Pedro, you want to know more about the clustered index at the source. So this is not a clustered index. It's a non-clustered index. So let's just say the best way to describe indexes very briefly are when you pick up a book, yeah, and you open the book, you have a list of all the chapters in a specific order in the book. And this specific order that you see in the book allows you to be able to go to a specific chapter, yeah? So you want to understand query folding, then you can look in the contents at the front of the book and go to page 72 for query folding. That is generally how a clustered index works. And a clustered index is when you build a table in a SQL Server, you generally build the table with a clustered index every time, so that it has a first ground for being able to sort information. And that is generally based upon the business key or the ID that is defined in the database. But then we also have other scenarios where you might be looking for keywords within your data. So, or within your book, sorry. So back to the book, yeah. You have in any of your sort of literature books, at the back of the book, a sort of keyword glossary. And in that keyword glossary, you could find query folding, for example, yeah, as a statement. And it would tell you that you will find information for query folding on page 72 and on page 96. So you would flick to those pages in the book. That is generally your non-clustered index. Yeah, so your non-clustered index points to where the data is. It isn't physically stored like the clustered index at the start and says it is in this order. It doesn't store it in a specific order, but it points to where the data is. So what's happened here is I've created one specifically on the day, and then I've narrowed down to a specific date. So it is looking and asking the SQL Server engine, when I pass over the predicate in the where clause, which is this part here, where can I find 2020-06-17 and 2020-06-16? And then it finds that information and is able to filter it very quickly because the pointers tells it where to go. So that is basically just very simple how the non-clustered index is working in the background. And the performance benefits when you are using a non-clustered index on a source database for your predicates is unbelievable. I'm talking up to 1,000% faster queries. Yeah, don't hold me to that one. Yeah, but it does make such a huge difference. So that's all fine and well. So I've got my index applied, I've got my date periods, but the problem is, as I mentioned, I would have to get rid of this filter and load all the data at some point. That's going to take 30 minutes to load into the, when I click close and apply, 30 minutes to wait for that to happen. I don't want to wait the 30 minutes for that to happen. I only want to wait a couple of minutes. So I want to leave this. So the option that I've got, and this was something that I mentioned earlier, was the use of parameters. So I create parameters, and I will just do that very, very quickly. Yeah, so here, create a parameter. And I will call this parameter my start date. And not necessarily required, but it's of a type date. And the current value, I will put what I've got in there. So it's 6/16/2020. And click on OK. And then I will create another one. And call this my, keep it the same, my end date. Sorry, and this will be 6/17/2020, for example. And then I click on OK. So what I've got then is I've got a start date and an end date. I then need to go back to this query and change this filter. And I can go back to a custom filter. Sorry, let me just do it quicker. So open it up as it was. And then I'll swap these values out for the parameters. So that was my end date. Sorry, I'm doing it a little bit back to front. Do apologize. And that was my start date. And then click on OK. Now, it will just send a query again. So just don't be surprised. Yeah, the blue donut of doom will disappear very shortly, I hope. Yeah. But this time, what I've done is I've then fixed these filters with parameters I can then utilize at a later date in the Power BI service. So the blue donut of doom is away. Now let's just see how that works in practice. In practice, so I'm going to close and apply. Yeah. So technically, I'm only loading 1 day of data, so this should be loaded pretty quickly. Yeah, I should only have to wait for a few seconds. And then what I will actually do is publish this to the Power BI service. So whilst that's going on in the background, I will probably go on to the next topic. It shouldn't take too long, actually. Just give it a second. I'll have a drink break. I'll have a bit of tea. So the time that it takes the data to load here is dependent on what you've got at the back end. If you have query folding, then it's looking at the server, the SQL server. So therefore, if I increase the performance of my SQL server at this point, those 24,000 rows that were loaded will load even quicker. Yeah? And again, if I reduce the performance of the SQL server, then those will load even slower. Yep. And then I just click on, I would just click on publish just to put it into the service very quickly. I'm logged in, so I don't need to do all this whole logging into the service. It'll all work relatively swiftly. And then I will go over to the Power BI service, which I have over here. And then I can see this scenario 2, which you can see that I have actually just uploaded. I can go into my data set settings, and once I have the problem that I don't have a gateway connection. I forgot to start my on-premise gateway. Just turn it on. Sorry, 1 second. I'm just signing in on another screen. Multi-factor authentication. Okay, so I'm online and I'm ready to use. So let me just go back to this connection. Okay, for whatever reason, I still can't see it. Anyway, not going to beat about the bush too much. Yeah, don't want to lose time. But here I have the ability to add parameters. So there you can see those are the parameters I passed from the Power BI desktop. And now I can change those parameters. So I can load and work with 1 day of data. And then when I move it to the service, I can change this to a different month, for example, or I can change it to a different year, and I can load everything. Once I've applied that, then I refresh my data set in the Power BI service, then it's taking care of all the heavy lifting. So basically what's happening now is the work is happening between the SQL Server and the Power BI service. And I'm not getting held up or slowed down in Power BI Desktop. So I have the ability to just really work at a tempo that suits me. So what this has also done is this has dramatically reduced the size of the data set that I'm working with as well. So remember we looked at that scenario where you're allowed 13 gigabytes of data for a premium capacity data set, but you can only upload 1 gigabyte of data. Well, this would be one of the ways to do that. So you would narrow it down using parameters to 1 gigabyte maximum in your Power BI desktop file. When you upload that to the service, you then go into the parameters, change the parameters, and then you get the ability to load even more into your premium capacity. And that's also how I like to work in general, with small amounts of data, and then go into the Power BI service and increase the amount of data that I'm actually then refreshing so that I can consume it, and I'm not getting held back during the development process. Yeah? So it's about being able to develop as quickly as possible for me. So that would also reduce the size of the file. Like I said, a huge amount of reduction in size. Obviously, we've got rid of the majority. I'm only loading 1 day. I think I got it down to about 7 megabytes for a day of data or something like that. It's relatively small, 7 megabytes for a month of data. So it was, even then, it was still quick enough to work with. What else we've got here is we've got the next reduction technique, which is getting rid of columns. I said you should look at columns and get rid of those that have a high cardinality, that I don't necessarily need. I find that problem a lot with a customer where they turn and say, yeah, but I might need that later. But yeah, that's later. Why wait now for you to need that later? It's not going to run away. It's still going to be there. We can always bring it back. Yeah, but why do you have to work with it if you don't necessarily need it for the KPIs that you're trying to build at this moment in time? So therefore, I know that I don't need the URL. That's something that I'm just not going to need. And it's also something that's going to have a high cardinality, because every entry in the chart is going to have a unique URL so that I can get that song off Spotify. So therefore, I don't want that in there because I've got no use of it. So I would get rid of that column. And actually getting rid of that column, and I'll bring that over, that would be my scenario 3, just so that you can see what I'm working with. Getting rid of that column reduced my main data from 170. We're down to 708 kilobytes there, so you can see. But it reduced my scenario 1 file from 171 down to 134. So I saved 20% of space just by getting rid of 1 column. Yeah, so it's always worth taking a look at and thinking about. And you always have the ability to come in here and look at your actual file, because this is a true indication of how much data you're saving into the Vertipack engine. So now we're going to look at the good, the bad, and the ugly. I think I need number 7 for this one. Seem to skip ahead, but I just built them so that I can go back and show any specific stage at any specific time. So I'll wait for my next scenario to load and show you some stuff here. Bear with me a second, please. Okay, so I have done everything that I wanted to so far. I have implemented a parameter there. Actually, I'm looking at several months worth of data here in this instance. And I have set up 3 scenarios, one where we have query folding, one where we don't have query folding, and one where we have query folding, but we have actually optimized our Power BI report as well. So if I just take a look at the steps so that you can see what's actually happening here. What did I do? I went through my Power BI report from the source. I removed some columns. I filtered some rows. I renamed some columns, changed the data types. I then went back and renamed some more columns. Yeah. Eventually, I went back at a later stage and renamed some more columns. Yeah. So sorry, this is taking a little while to load. If it does take too long, then I will just go through the steps in in the original version, because here I'm playing about with a bit more data and it's multiplied several times. But basically what I've done is I haven't modularly built this report. Yeah? So if I were to go back into my Power BI 1, just to show what I've done, I've went here and I've said, okay, I don't like this. I'm going to rename this column to title. And then I also don't like this data type. I'm going to change that. I want a text value. And then I'm going to go in and rename this again. See, here we go. We've got the blue donut of doom that I don't like. Yeah, it's still cropping up on us. Still got to wait. Yeah, hopefully not too long. Only the time it would take for the query to go back and run. Yeah, but it's working on its own engine at the minute. Yeah, but this is what I've done in the demo that you could that's still loading, unfortunately, in the background. Yeah. Sorry, that was, let me open the first one. Yeah. So this is what I've done as the this is the ugly. Yeah, it's not necessarily bad. It's just generally ugly, because what I've got is I've got these steps where I have renamed columns multiple times or removed columns multiple times, because I've worked iteratively through the different columns that I've got to get rid or to make changes to my data. So I've changed the title, I've changed the data type here, then I've changed the title of the column, and then I've done done a transformation here, and then I have changed the title of the column again. So every time I'm doing that, I'm creating a new step. As I said earlier, each new step that I'm creating is always going going back. And it's way harder to find undo. Yeah, totally right. It's way harder to find and undo anything with the ugly. I don't like it at all, because you're a bit lost about what's going on. And this was a scenario where I say that if I'm not using groups and I'm not documenting my work, then I don't really know why this step is here and what's been done. So I should always try to find a modular approach. So I should decide, okay, what do I want to do first? What are the easy things, getting rid of that data that I don't need, for example. And then I want to change the headers. If I can't change the headers of the columns back at the source, then I change the headers in one step. Yeah. If I know that I'm going to be doing something where I'm bringing in new columns from another data source, then I integrate that data from the other columns first and then change the names. So I wait for that step to happen. So it's maybe one of the last steps I do and not necessarily one of the first. So it's all about making your approach more modular. So by saying, okay, I want to filter the data, now I want to do this, and now I want to do this. And it's all about adding those steps so that we get the good, but this is not necessarily the good, yeah, but I've just optimized it. So it's the same process, but what I have got is I have added my additional conditional column, I've removed columns, I've filtered rows, I've renamed columns, I've changed types, I've calculated the day of the year, and I've replaced the value. So I don't have any steps which are repeating. I've compressed them all into one. It's the same result at the end of the day. What I've also done here is I've added information. And this is what I mean about documenting your queries. So I can hover over this little I symbol that I've got, and it says add conditional column for trend and change to movement. So I know what I've done and maybe why I've done that. This is obviously more important for complex steps, but for simple ones, it's important too. You can easily do this by opening the properties and adding the text into the description. Or if you're more like me and you like to work in the advanced editor, then you just put a / above the step and then add your comment there. So it's a bit like adding comments to your development code. Fairly simple. And then we have the bad, yeah, which is where we lost the ability to query fold very early. And that was through adding this step here, keep last rows. So rather than keep the top rows, I went for keep the last rows. Now, if any of you do have experience working with SQL Server, you will know that I can select top 200 or 1000, but I can't select bottom. So because I can't do that in the source system, I then lose the ability to query fold. I can see it was there available, and then I've lost the query fold there. I have now lost a query fold all the way through the rest of the steps that I have completed. That is why it's bad. Yeah, just through adding one step and not paying attention, I've now lost the ability to fold my queries back against the source at every step possible. I want to make that possible at every step. And if I can't make it possible at every step, then I want to add that non-query folding step somewhere near the end. What I've also done, which is very, very bad in all of these, is I have sorted rows so that you can see what's actually going on. Because when I sort rows in Power BI, so then it's probably one of the worst, one of the heaviest operations that you can do back on the server, as far as after you've filtered then to create an order, because it needs to look at all the data and be able to then order it by that specific column. So therefore, it's a heavy operation. Even on the database side, you just need to think about what the process is in the background, what could be happening. In order for me to order, I need to get all the values and then order. Yeah, so it's a bit about understanding what's happening in the background with the system. So what I'd done is I'd done some diagnostics on these. I created some diagnostics. I'm not going to show you them in this one. I'm going to show you them in my scenario 9. Because I've got everything in there, and I'm also cautious at the time, and I know that people have maybe made appointments at 8 o'clock and want to be stepping out, so I don't want to overdo it here. So here's one I done earlier. Yeah, please don't worry too much about the whole graphics and why they look the way they look with the colors. It's much easier for me to transport the information this way. This is how it comes out natively anyway. Yeah, and I can see here the individual steps, and they're always the same color between both queries. So here I have the example of no query folding versus query folding, and the exclusive duration in seconds for me to load 3 months worth of data. And I can see somewhere in the middle here, I have a big fat problem going on. Yeah, so this is one of the removed column steps has created an issue. It's my remove columns 1 step, so not the remove columns step that might have came somewhere before it. Yeah, so I think it's there. So I got remove columns. So here I wasn't modular. Yeah. You can't see the report, honestly. Can anyone else not see the report? Can you guys not see my screen?
No, I can see it. No, for me it works. Yeah.
Okay. Maybe try jumping out and jumping back in.
Let's sometimes solve it. Yeah. Sorry.
Or do you want me to stop sharing and reshare? You can see it now, Pedro. Yeah. Okay, great. Yeah. So here I can see that I got this big fat area, and that's where I wasn't modular in my work. And actually, Power BI is like, why didn't you get rid of all the columns in one swoop and make life easier for me? And it's causing some issues. Another area, problem area, is this sorting rows. And here you can see both on the no query folding and the query folding. This is a step that takes a long time. This is actually taking longer in the query folding because at this point in the non-query folding, I have my data in my system resources on my laptop. So it's got a quicker way to look, yeah, because it's got some of it cached and some of it hasn't. This is going back to the source, and it's actually taking longer. So this is a big bad, yeah. We don't want to do something like this. Now, here you can see a clear difference between a query with no query folding and a query with query folding. It makes a huge difference. Yeah, if we look at each individual segment, pretty much every segment, every step that I have taken takes longer when I'm not folding the query than it does when I am folding it. So that's why we always go on about it, yeah, to try and utilize query folding. Now, comparison 2. I am then looking at no query folding versus query folding. Now I'm bringing in my optimized version, where I modulated all the steps into a single step. Look at the efficiency win that I have just by doing that. It's massive, yeah. So I'm getting query folding, I'm getting optimized. But what I did do, just to cheat a little bit, is I got rid of that horrible sorted rows because I would never do it anyway, yeah. But even if I just pulled this sorted rows out, we are still quicker by optimizing because we've just reduced the number of steps. We can see that each step is taking around about 5 seconds to be computed. If I add 20 steps, then that's another 100 seconds. Yeah. So just bear that in mind, that I'm always need to be very cautious. Taras has got a question, so let's just let Taras ask before we proceed. Can you do that, Christoph?
Yes, wait a second. I will unmute you, Taras. So your microphone should work now in case you want to ask your question, Taras. Or you can use the chat, however you want.
Okay.
Okay, sorry. Okay.
No questions. Okay. No problem.
Solved.
Yeah. So this is the this is where we so looking at, we can see that this query folding and the optimized query, so breaking it down and making it modular, I know that each step is taking around 5 seconds. Yeah. Still generally a little bit quicker than the query folding itself, but it's debatable. Yeah, some of them are maybe slightly longer, but this is what I want to be trying to achieve. Yeah, so this is where I can see that each step is taking roughly the same amount of time. So there, it's all about the processing time that it requires. I can't get away from that. These are the big things that I need to be looking at, and things like this, for example, that are just sticking out. If any of you did pay a lot of attention, you might have noticed that between comparison 1 and comparison 2, something's also changed, as far as the exclusive duration was concerned. And then this will change even more dramatically when I go into comparison 3. So I will go into comparison 3, and this is where I used query folding optimized, and I also created a model. So I pre-modeled my data and created a fact table and lots of dimensions, and I wanted to see if that would be quicker. Now, the fact table and the lots of dimensions that I created was not quicker. It was actually just slower than the query folding optimized for the same amount of steps that were conducted. But I now have a star schema already ready to go, when I move into the modeling phase and to work on in DAX. So I don't need to do those transformations that you might be already doing in Power BI, where you are going in and actually breaking the flat table down into a star schema by breaking the tables down, joining them with each other, creating indexes, because creating an index actually breaks the chain for query folding. So not recommended. Therefore, if you do want to model using a star schema, which is the preferred way, you should go back and create those at the database level. So I did get asked the question, where did I create those? I didn't create them with a data flow, no. I went back to my database and I created those tables in my database. Yeah, very simple. Just by creating the tables and creating an index, I will go back and I'll show you exactly how those are structured. But it is just built so that I have key values and then I can match the key values. Okay, then what I have also noticed here is that between what happened here, let's look at this query folding instance where I took an exclusive duration of 150 plus seconds, and then look at the next comparison where the query folding was only taking 34.17 seconds. Yeah, what's actually happened there is I cleared the cache out of Power BI before I went and proceeded. But what it doesn't do is it doesn't clear the cache in my database in the background. Now, I have a buffer pool cache in the background of my database, and that buffer pool cache stores the query plans for all the queries that I run until it's full, and then it overwrites them again. So just be aware that if you're running the same queries regularly, like I was doing here, because I'm always firing the same queries one after the other, then actually what I'm doing is I'm caching these. But it doesn't matter too much because the results here have also increased. Yeah, as though they're also faster. So I can still get a good comparison, but just be aware that you've got caching mechanism in Power BI where you might need to clear the cache, but you also have a caching mechanism back in the data source where you need to clear that buffer pool cache or that transaction cache, whichever it might be, depending on which database you are using. So for each of these steps, when I created the report, I then have the ability to look at what's going on in each of those. So these are the several scenarios that I run. And I'm just using the aggregated diagnostics. And the aggregated diagnostics gives me the information on the query that is being run in the background. Here I can see the source queries that crop up. And I can see the exclusive duration that this query then took in seconds, for example. For those of you who don't know how I've done this, I'm just going to demo it very, very quickly. Yeah? But I go to my tools in Power BI, and then I create a diagnostics by starting the diagnostics. Once that diagnostics is started, Power BI is just opening a trace window and waiting for me to do the next steps. So it depends on what I actually want to test. So I want to test the vStreams table maybe and understand how long that's taking to load. So I'm going to go back here and I will refresh the preview specifically for this vStreams table. That happened very quickly, yeah. And then I will just do it for this table as well. Yeah, we've seen it's only a couple of seconds in the background, or less than a couple of seconds. It's less than a millisecond, so therefore, it's not an ideal effect. But I have the ability to then run it what I want to gather information on and create some diagnostics. Once I'm finished by refreshing the previews of each of the individual report components or queries that I have, I then go back to my tools and stop the diagnostics. If this is the first time you've done this, you will get a folder created, and they will land here. As you can see, I was playing around most of the day with this yesterday, preparing it, so it's not something that I've done. I've done this specifically for this video, and therefore I've got the ability to then here look at these. Basically look at this information. The detailed information is a bit much for starting off, so therefore I would always recommend to go to the aggregated, but I would just recommend making one very, very small transformation before you do, and that is transforming the exclusive duration into seconds so that you can actually see it from the perspective of seconds. I'm just going to enable this in the load so that I can then see it on the Power BI side. That will close and apply. Won't take too long because I'm only loading this one new table in. And I believe that's this one here, so the 17th. Just going to create a new window and open this up. And the information that I'm interested in, as you've seen previously, are the exclusive duration. I have the percentage value, but I also have the standard exclusive duration. And I want to understand which steps are responsible for that exclusive duration and the queries as well. So I'm going to put the query on the axis actually and move the step to the legend. And then I would put that into a stacked bar chart, yeah, which is here. And then this gives me a good idea of what steps I have, how long they're taking in seconds so that I can much easier understand it and then identify where do I have areas that are slowing me down. It's crazy how many people don't know that you can do this or how simple it is. Yeah, it's literally just a few clicks to be able to get this result. And it's so valuable to be able to see, hey, where are my reports being slowed down? You know, so look for the big boxes. Those are the areas that are slower than every other area. And yeah, it's a valuable tool that I use all the time. Thanks, Martin, Tyree. Obviously, something that you guys are possibly seeing for the first time. Yeah, very nice and very valuable just to open up your reports and do a first analysis when you go back to work tomorrow. Yeah, to understand yourself, what's going on. So let me just go back and check. Yep. So I also did break this down into a model because I wanted to understand how quick it would be rather than working with a flat table, working with a model. So the same amount of data broken down into a model. I created these tables myself back in the database. So it's exactly the same tables, just by selecting the distinct values and building my dimensions, assigning an ID to the dimensions, and then writing these IDs into the fact table and using it. Why did I do that? To test it? Because I wanted to understand I'm actually creating more data. I'm creating more columns, but what I'm doing is I'm using value encoding more often than I'm using hash encoding, because we've seen that value encoding can be done against numbers and the hash encoding is done against other values. That's right. Yeah, Fernando, Azure SQL database. That's correct. So scaled at DTU 100. So that's what I'm using these. I wanted to understand what happens when I try to force the use of value encoded values over my fact table. And actually, I'm using the full data set that I was using. So this isn't the full data set. This one's filtered. But using the full data set, I moved from 134 megabyte data size, file size, to 120 megabytes. It's not massive, yeah. 20 million rows of data, 120 megabytes of data, yeah. And my yeah, so basically I was able to, even though I'm creating more columns and I have more columns, I was able to reduce the amount of data. But not only that, but having this model already for me in advance ensures that the transformations that I want to make are actually generally quicker, because I'm working on smaller amounts of data each time. For example, I have this chart where I replaced a value to make top 200 stick out. For example, that was one of the criteria that I used in my previous. I was able to do that and really just test, hey, when I use the same steps, do I get the same results? Is it quicker? We've seen that it wasn't necessarily quicker in overall when looking back at the report. And that was this one. Yeah, because if I count all these individual steps, I come up to over 2.36. But that first step of pulling the query is generally pretty heavy, as we've seen in the, as we've seen just in that one example where we only had the small amount of steps. So therefore, it could be related to that. If I was working with a larger amount of data, I would expect maybe quicker results, yeah, from the model. But I don't have to create that model in Power BI now. I've got it in the background. So really efficient and makes my life easier moving forward. There are some dynamic management views that I could use, for example. So I did create, so in the SQL database, and that is where I have created this very small, very simple report. And this is doing a live query against my database. That's why I had to refresh it at this moment in time. Yeah, I've just loaded everything, which is a bit of a pain. Sorry, not necessarily the desired effect from myself. But what I wanted to try and show you here is that there's dynamic management views on the SQL Server, so that I can understand also how many queries are actually being pushed to the SQL Server in the background every time I refresh my report. And this is where it was identified that going back to, just going to cancel it, sorry, because I'm wary of the time. Yeah, but I'm going to go back here, and that's where I noticed that for the majority of single steps that I have here, where I'm conducting transformations, that these single steps are pushing a query back to the source system. So this is where you should also take care, and it's sort of the last sort of words that I want to finish on before I leave. It's not only just about the performance that you've got whilst you're offering the report, but if you imagine that you are the report offerer or the developer who's creating a report against your operational SAP system, then for every step that you create, you are pushing a query against your operational SAP system for every single step. That's why we want to reduce those amount of steps so that we can reduce the amount of transactions that are being fired. Now, that's okay in a self-service scenario where we have a managed service in the middle. But if you imagine that we have 20 people all doing self-service BI at the same time, creating reports and not doing it very well, and building lots and lots of steps, we've got hundreds and hundreds of queries going against the source system. And that's something that sometimes is forgotten about in the background. What's actually happening underneath the engine is that there are these queries firing back against the source every single time, and those are going to cost you performance on your source system. So those are my last words for this evening. I hope you enjoyed what you've seen. Sorry, it's a little bit quick fire with me. I do understand that it's the same last time. I rattle through it fairly quickly. I want to try and give you as much as I possibly can so that you can utilize. And if you have any questions, please feel free to use the time to ask them now. If you don't want to ask them now, reach out to me, as I said, on LinkedIn. If you want the data that I worked with or want the Power BI files to have a look at yourself, quite happy to send them over to you. You just need to reach out to me, please.
Yeah, big thank you, Kris. Amazing talk. It's always good also that we cover this Power Query side of things, because that's always, in my opinion, sometimes not really taken into account compared to DAX, but everything starts with Power Query and using these features both from a performance optimization, but also with parameters you can do. You can really create these dynamic queries. So that is really great. With the files, we can also provide them in our groups OneDrive if you want. Yeah, and then if there are questions, just write them in the chat, or we can also unmute you if you want to ask something more complex. So a lot of thank yous. Totally agree.
DAX Studio. What about this? So I already was quite astonished one time when I compared in DAX Studio one table of sales which has quantity and price, and one with quantity, price, and the calculated sum, because the sum has much more unique numbers, and it was so much less compressed than the rest, and the table was not like twice the size, but like 100 the size.
Yeah, it does make a big difference, and that's one of the reasons to sort of not do that calculated column in DAX, and to really just do it as far back as possible. And when we speak about as far back as possible, it's always as close to the source as possible.
Yeah, but this is exactly the opposite, I think, because if you have like price, quantity, and the full calculated sum in the database, so the query is very fast. It's cool because you will not even measure it because it's just a number. I think the data is maybe big, but it's just one column after all. But it's not so compressed, so not compressed as well as if you just skip the sum and just use a measure.
Okay, wow. You're talking about using a measure, right?
Yeah.
Okay, but that's always going to be the quickest way, right? Because you're like creating a measure, so it's not creating a calculated column with DAX. So we're talking specifically about creating a value at row level, because DAX during the calculated column saves a value for every row, right? If you create a calculated column, whereas a measure saves it and compresses it and then does the maths at runtime, right?
Yeah, it's always a trade-off, of course. Yeah. Another question from Martin. He's asking if there is a best practice for the modularized thing. What should you do first? I think there is one, but I'm still searching.
Yeah, I mean, I've tried to, Martin, it's a good question, because I've tried to look around and see what other people are doing in the community. I've also created one for myself, for example, that I use. But even then, it's still subject to failure, because sometimes I come across a scenario where I need to do something early on that I wouldn't normally have had to have done. So it sort of puts a stick between my spokes. So therefore, I try to just keep the modular steps that I need to do as like a sort of goodie bag, but don't don't fulfill them in a specific order. I do something, you know, natively just by not thinking about it. I do it in a specific order, but I also feel that sometimes I do have to move steps around and move some things around to suit the situation. Yeah, but I mean, if you do find anything, Martin, happy for you to share it amongst the group, or if anyone else has any input on that topic.
Maybe so. I think this. No. Maybe I will find it until the end, but I also think there's not really like one golden rule for this. You just, of course, have the ones that do not break the folding first, and if you really need something that breaks, it should be at the end. Yeah, okay.
Yeah,
very simple, but
there is a question there that says, doesn't this mean the query folding happens for the entire query and not step by step, provided by the whole query is folding? Yeah, so basically you're right. So what happens is you would see that on the steps, as I go through each step, the additional step is added at a later stage, is added at the next stage. So what is happening then is pushing back that query, or it's basically, it's taking all the transformation steps all the way up as it goes through until the end. And then the end step includes all the steps. So if I had a where filter, if I had an order by, if I had a join, those would all be added if those were separate steps at the final query at the end. But then looking back at what's happening against the database in the back end, so running the profiler against it, because that would be, that was my initial expectation. I should only be running one query against it because I want that result set. But actually, it's still going back and collecting some interim information in between. So where I was expecting just a single query to be running for 10 steps, what I was actually getting was 7 queries running against the source system. So very, very, very slightly deceiving on that point, actually. So it's not the case, tried and tested, and quite happy to provide the file so that you can test it yourself. So.
Great answer. Okay, then.
I hope we didn't miss anything. There were so many comments.
Yeah, Martin is talking about the grouping because grouping is, as you said, it's expensive, but it's still important to use it anyway. But as you also said, Kris, if you have the possibility to create a view, do this. If you just load the data into Power BI just to group them, then you should really try to group them first. But if you can't, of course, then it's better to group than not to group. Because at least
there's always the trade-offs also for your company, or for your workflow that way where you do it. So if you can do it in a view, so just that you can do it in Power Query doesn't mean you should do everything in Power Query. So if you have a view and then everyone can reuse it, or have a data flow, which is then also Power Query basically, that's also an option. And then you could do the grouping there already, and not necessarily do it in Power Query. So I set this golden rule always as close to the data source as possible. That would also mean as a view, and then just load this into Power Query.
Yeah.
But sometimes you have to do it in Power Query.
Yeah. And I already separated parts of Power Query into data flows just for not only for performance, but more for research reasons. If something breaks, then you have to look, was it this data source or the other one? And if you have something isolated in a data flow, it's easier to find the problem.
There was one more question from Fernando. What's your stand on renaming query steps?
Yeah. Great. So Yui has some best practice, but it's just, I think, one.
So I usually don't rename them. There's just like I have for me sometimes, but this depends on the script when I actually coded something in the advanced editor. So where I wrote an M function that so I didn't use the UI and I actually coded something manually. Then I rename the step and tell me, hey, here I did something manually in addition to the comment to know this. But besides that, I usually don't rename. But
yeah, I on the other hand do. So just to pull another perspective into it, I do rename the steps, and that's I just like everything to look as intuitive as possible, as easy to read, as understandable. And if I can save myself the documentation of the step, then I will rename it and keep it short so that you can see exactly what's happening at that step. And then if it's more complex, then I will go in and I will create a comment within it to then increase the amount of detail that
comments.
I have.
I agree.
So therefore I do generally change the steps, the names, and also I've picked up documents, especially being native English speaker here in Germany. I've picked up Power BI reports which have a mix of languages. In Power Query.
Yeah.
So you have half of the steps in German, half of them in English.
Right. That's right.
It's a disaster. So that's another reason for I like to try and keep to a standard format.
That's always set mine to English, that not to at least go back to this, because the German naming is also sometimes very weird. But yeah, there I agree in that regard. Do you use data flows often, or do you prefer to do the transformation in desktop?
Oh, I'm a database guy. So I love data warehousing and working with the database. So I actually do as much as I can back on the source system on the SQL Server as I possibly can. So that's why I would actually do the majority of my transformation steps, build my model, and then basically I don't have to do anything in Power BI or in Power Query. But I know that doesn't suit anyone. It doesn't suit everyone. But for normal people. So,
I can answer you too, Fernando. So I don't use it all the time, data flows. I use it when it either gets just too big. So even bigger, I also use the parameter thing that Kris uses. But if even with this, it's not about size sometimes, but sometimes I have like 8 different data sources, and one is not so stable or has bad performance, and if one breaks, all break when you refresh. So this sucks. And in these cases, I always try to isolate the more like problematic data sources in another data flow, because if the data flow refresh fails, you still have the old data and the whole report is still okay. So the rest of the other data sources are still loaded and everything. So this is one reason for me to use data flows, like for some unstable data sources, and the other is just the size and also performance reasons, but I don't use them as a routine, so but only if needed. And to be honest, I often also model in Power BI Desktop and then just copy paste it to data flows, because I still like the on-premise editor in Power BI Desktop more than the online.
But you can do copy paste mostly, so that you can do it in desktop and then move it to a data flow, either to share it with others, or as Arthur said, I also use it for things that break or can break. And then, as he said, only the data flow fails, but your report is still up and running. So totally agree there. Also be good to avoid scenario.
Of course. This is also another use case. Thanks, George, because when I use like SQL database in Azure, it costs me per calls. So I also use data flow sometimes when I test something, just to cache a paid account when I use the database. So I load the database into the data flow. Do not refresh there, only if needed. But then I can test everything, because if you connect directly to Azure SQL from Power BI Desktop, I think at least at every commit of Power Query, it will load and you will pay for the transactions. Yeah, another good use case.
Data flows really improved. So, and especially with premium or premium per user, it's really it's nowhere near to when they started it. There it was, I think we all tried it out, and then no.
Yeah, Fernando, it's also. Oh no,
it's really good.
It's cool, like Fernando, what you say, that the look and feel of data flows is in some kind it's better. The schema view, the visual indicators, also some other cool stuff. But yeah, it's still it lacks the external tools. It lacks some easy copy paste stuff you can do from, like, to manage your standards more. So for real development, I would use desktop still, even if I'm waiting the data flows, the editor becomes that good. Really, because
and also with Pro, there are also some limitations compared to Premium. So if you're not on Premium, then sometimes you can't do the same things that you can do in desktop and data flows.
Yes, thank you too, Paul. Have a good night. And another one. Also have to admit, so data flow is normally not a database. It's just I often use them as a buffer, but it's a buffer. So it's if you use it too much of like a kind of data lake, it's possible. This is cool about Microsoft. You can do a lot of stuff, but at least you still have to remember it's data flow is not a real data lake or database.
No. But there are scenarios where they come in very, very handy. So
yeah, definitely.
Okay, I think we covered all questions. Otherwise, post it again. Thank you too.
Yes, thank you.
Have a good evening.
Yeah, good. Oh, you're still recording, right?
I'm still recording. I'm recording Q&A session. Let's see. I think Kris having another record length.
Oh no, I tried not to. I didn't want to start the year off like this. Don't say that.
I think it's almost.
I'm sorry.
On par with what we had.
I'm not coming back. It's okay.
No, I mean it's also a good sign. I always like these demo-heavy things. They also take a bit longer, but I think it's worth it.
It works. You're very well prepared. So, query folding against Oracle. Oh, this is your database specialist master question.
That I don't know.
It's still SQL, but
there are some sources where it also works.
Yeah, I even know that some OData,
if it's Oracle,
the OData web APIs can also fold in some cases. So the real it depends on if you can send all the transformations, if you can pack it into the query. So at least I think nobody of us know. No Oracle guys here.
Yeah, I mean, query folding will work against an Oracle database. Yeah.
Okay.
it will, because any database that accepts SQL commands, it doesn't matter, PL, SQL from Oracle, they will still, as long as it's part of the ANSI standards, the SQL that's utilized or the transformations that are utilized, then they will run with query folding against an Oracle database. So, yes.
Yeah, great. Gateway, I think gateway is not a problem, right?
No,
it's just the authorization.
Yeah.
No,
it's a pass-through mechanism.
Yeah. Cool. So here you see how much this topic triggers the people.
Yeah, it's good.
Never got so many questions.
They don't want to let you go.
In the chat.
So good. I think we should cover data flows next in more detail. Data flows parts,
Yeah, we already did it last year, actually.
Maybe we need a recap on the new features or something.
Workshop with Martin. Yeah. And
of course, but yes, for the last ones was still here, and the next 3 talks are already in planning.
Yeah,
and not open yet, but there will be one talk about the DNAP visual. There's some more visualization part of Power BI, where you can create your own visuals by low code. And then from the Power BI guide, Ben Ferry, then there will be a talk from Matthias Tierbach about the Power BI tools, some more developer stuff for DevOps and version control in Power BI. And then in April, we will have a talk about planning, deep dive into planning with one of the tool providers.
Nice.
March 15, 24, and April 7 is the current planning. So don't worry, they will be online soon, but in case you want to save the date.
Yeah. Okay, and then
good.
You got 1,000 persons. Time to party.
Okay, great.
So thanks, thanks everyone. Thanks, Kris. Really great talk.
Thanks for having me.
Have a nice evening, everyone.
You too, guys.
Everyone.
Take care.